Now, let's say for a minute that instead of having this 10 value data set, let's say that there's this crazy school in the district. Okay, and I mean, it's nuts. It flies Bill Gates in twice a year. It's got, 5,000 kids. They've all got MacBooks and iPads, and I mean, they got all the bells and whistles. And let's say that their annual budget is $50 million. I know that that seems a little silly, but it really could happen. So in terms of the data, that would be 500 hundred thousands, right? So we end up with $50 million. Now, the new mean, if I plug everything in, again, I'm going to show you how to do all this on your calculator. You can throw this data set in, you can add 500 to it to see what happens, et cetera, et cetera. But when it gets spit out, the new mean is 63.36. But remember, this equates to 6.3 million. Now, you may be going, Ripley, why don't you just write these things in terms of millions? I'm doing that for a reason. You're often given data or charts or graphs in these really strange units. So you got to kind of get used to setting your brain so that you can translate back and forth from hundreds of thousands to millions, et cetera, et cetera. All right? Now, watch the problem here. 63 million, whoops, didn't mean to cross it out. $63 million doesn't represent any of the data in this data set. I mean, look, the highest, if you exclude the 500 or the 50 million, the highest is $4 million. So 6.3 million, I think I said 63, I meant $6.3 million isn't representative of that at all. It's also not at all representative of the 50 million. It's not even close. So what we have is, what we refer to in the mathematical parlance or in the statistical parlance is we have an outlier. We have this crazy outlier number. And what this number is doing is it's pulling the mean to it. Remember, in absence of that guy right there, our mean was 19.5. You throw the $50 million school in and the mean gets drugged to it. It gets sucked over all the way over here to 6.3 million. All right, or 630. Whoops, yeah, 63.36. Okay, so the problem with the mean is, let me change the color of my pen. The problem with the mean is it's really susceptible to outliers. It gets slapped around. If I had a really low number here, let's say there was a free school that didn't cost anything, you just wander around the woods all day and everybody volunteers and everything's given to them, then that would drag the mean back towards zero. Excuse me. So we have this quote-unquote measure of center that doesn't really measure anything because none of the data is represented by that outlier, okay? Or excuse me, by that mean. Whereas over here, when we had the 19.5, at least these guys over here were sort of representative of it. The bigger the data set is, the more the mean will represent a true center of the data, okay? So what we do with this, in the case of a measure of center that we want to be more accurate if we have this outlier value, is we use the median, okay? So the median really is the physical center of the data. Physical center of the data. All right, and I'm going to give you one more example with just some real small numbers to play with too, just to let you guys play with this just a little bit. Okay, so like I said, conveniently I have arranged the data from least to greatest, which makes it a lot more useful. Let me go ahead and erase all this gibberish over here. Get rid of that, get rid of that. Pardon me for just a second. And get rid of that. Ooh, look at that, good erasing. All right, now all that you have to do to find the median is line up. The best thing to do is to sort the data first from least to greatest, which has been done for you. The other thing is to write down what n is. In this case, I've got 10. All right. So then all I do is I march over 10 values, or excuse me, I march over 5 values since it's the physical center of the data. So I just go 1, 2, 3, 4, 5. Now, because we have an even number of data values, that implies that there should be, wherever the median is, there should be 5 data values below it and 5 data values above it. Well, that's nice, because I got myself 5 data values below and above where the median is. This right here is the median. Now, Again, because I've got an even number, what I need to do is take the average of these two numbers, which is really easy to see that it's going to be 20. But again, I'll show you with a couple of different size data sets that sometimes there's a little bit more mathematics to it. Okay? Excuse me. So the median in this case, the median is 20. Now notice the difference between 20 and 63.36. All right? Notice the difference between 20 and 19.5. 19.5 and 20 are really, really close. Now, let's go ahead and figure out the median when I have this new data value. Now notice that n equals 11. So when I go to look for the median, watch what happens. I've got 11. I'm going to go ahead and erase this for just a second. Now, I can't go over 5.5 values, so what I do instead is I just round up to the 6th value. So I go 1, 2, 3, 4, 5. Half of 11 is 5.5, but there is no 5.5, so what I do is I just jump up to the next value, which in this case, this is my median. Again, it's 20. That's a really cool phenomenon. Notice, with or without this god-awful, nasty monstrosity of a budget, the median was still 20. The median is referred to as resistant to outliers. In other words, outliers don't pull the median, notice 20 to 20, versus 19.5 to 63.36. The way that an outlier can pull the mean. The median is a really, really powerful measure of center for that reason. All right, let me give you a couple of interesting data sets just for giggles. All right, let's create a data set we're going to call, let's say, 2, 4, 6, and 8. All right? Excuse me. If I wanted to figure out the median for this guy, now again, notice that n equals 4 because there are 4 data values in the sample. I would count over 2, but again, I've got an even number. So the median actually lives between the second and the third values because you want a value that splits the data perfectly in half. So in this case, the median is going to be 4 plus 6 divided by 2, which is 5. So the median, even though the median is not in the data set, it's 5. Okay? Nothing to it. However, if I added a 10 to this data set, now the median would fall exactly on 6. Because, let me go ahead and erase here, because 6 is the split between the bottom, these two data values, and the top two data values. And even though it represents a data value, it's still, that's what we say the median is. Okay? So hopefully you see how a median works. Hopefully that was helpful. All right, cool. That's the median. Now let's go ahead and move on to the mode. Crank over here. The mode is simply the data value that occurs most. Now, so I've been yelled at for this, but I believe it to be true. This is mostly, no pun intended, mostly, see most, mostly for qualitative data or categorical, so qual data. Now, let me show you why. I stumble back here if I want to do the mode on the data value that I created before. Now, in this case, if you look through the data, the data value that occurs the most is 20. Now, we just got lucky on this. We got kind of crazy lucky, and I'll create a sort of a crazy data value or excuse me, a data set where it doesn't work. In this case, wow, what happened there? In this case, the mode is 20 because it occurs twice, and all the other data values occur one time exactly. Now, let me show you what can happen. Let's say that instead of having this data set, I'm going to add 2 more data values to it. Let's get rid of this crazy outlier. That thing just made all hell break loose. Let's say, for example, that I added 2 more 5s. So I've got, now instead of having 10, I have 12 data values. Now I realize that that's going to change the median, and it's also going to change the mean, but we're not afraid of that. I'm just doing this to make a point. In this case, the mode, I'll write it down here since we got a little room. If I add these two extra 5 values right here, so it would be 4.5, 5, 5, 5, 6.5, 7, 7, or 7, 20, 20, etc., the mode would be 5. Now notice, again, while the mode is 5, there's no doubt about that. All these values way over here, really from 7 on, from 20 on, that doesn't really represent anything for us. It doesn't help us. Not like when we had the median of 20 and the mean of 19.5. That was far more representative of the physical center of the data and the average of the data. So what we do the mode for is, what we use the mode for is we use it for qualitative data. For example, let's say that I took a poll of the color of shirts in a classroom. Notice that's qualitative, not quantitative. And you had 5 blues, 7 grays, 8 whites, and of course 3 pinks, one of which I may be wearing. You never can tell. Well, it's very difficult to talk about this in terms of finding an average. I mean, what are you going to do if you want to look for X bar? Are you going to add up the wavelength of the colors? Let's see, a blue plus a gray is like a bruise, plus a white is a light bruise, plus a pink makes it a fuchsia or a mauve. Doesn't make any sense. Or brown, or God, I don't have any idea what that. You artists in the group would be able to tell me. So this is just it's not going to work. All right. So if I try to do the median, how does that work? Again, am I going to line it up by wavelength and find the physical middle of the data set? It's not that there's no order to it. This is an absolute nominal level of data. So there's no order to it. So I don't know if which is better than, in other words, opinions vary in terms of which color is better than others. So what we do is we grab the one that occurs the most, and this is referred to as the mode. Now, is our 8 white shirts representative of the pinks, the grays, and the blues? I guess from a scientific or an artistic, I forget which is which. White is the collection of all colors in science, and it's the collection of no colors in art. I don't know. I don't know. A little non sequitur there for you. But at least with qualitative data, we have something we can sort of grab onto. Now, referring to this as a measure of center, it's a little specious, but we have something that we can hold on to in qualitative data and say, okay, well, here's the mode, here's the data value that occurs the most. Right? Those are the big daddies in measures of center. They are the ones that you're gonna see the most, and you'll really see the median and the mean the most. But every now and then you'll hear the mode get squirted out. So hopefully that was helpful. We'll play with a couple extra ones in the next little lesson, and then we'll be done with the first section in chapter 3. All right.